Hey guys, welcome back to problem 5-7 from the fundamentals. Alright, as I've said in the past, these fundamental problems are key to you acing this course. You can do any of these without looking at solutions or anything like that. You're all set in this class. Alright, so what I just started drawing was I'm drawing all the forces that are acting on this body. Okay, we can call these the reaction forces because here we don't really have any supports other than the cables. Okay, so we have TA, TB, TC. They give us the distances, right? And they tell us one thing that you can't miss out on is that the weight of this plate, the uniform plate, has a weight of 500 pounds. Okay, and you know it's a uniform rectangular plate, so it's going to be right down in the very center of this plate. All right, and this is 500. All right, so 500 pounds. So now next thing, we're done with step one, putting all the forces on the diagram, right? Now we just want to sum all the forces in the y direction, okay? And we know it's static equilibrium. In the x direction, we don't have any, so you don't have to draw that. In the, oh my goodness, this is the z direction, sorry. In the z direction, okay, because everything is in the z direction. So now, wow, that's annoying. Now we're just gonna put these all on the summation of forces equation. So TB plus TA plus TC, and then on this side, so we have minus 200, minus 500. We bring over to the right hand side, and it's 700 pounds. Okay. Nice. All right, so now we have this. Okay, we have one equation and three unknowns, so we can't really do anything with it. So the next few, which is what this chapter is introducing, is the new static equilibrium equations of moments in the x have to add up to 0. Okay. Moments in the y add up to 0. Moments in the z add up to 0. Okay, so I guess we'll put this one here. And y. And what that means, it's mx is you're summing the moments that try to make the plate rotate about this axis. Okay, so think about the plate, flipping in this direction like this and going around. Okay, so let's do that. Let's start with mx. So if you have a force, okay, and it's already on the x-axis, that's just pushing on the x-axis. It's not trying to make it rotate about the x-axis, okay? So that force wouldn't contribute any torque or moment. So this TB, it's already on the x-axis, so that doesn't contribute any moment, okay? Now let's start with TA, okay? TA, if it pushes up on this corner, okay, it's gonna try to make it rotate in this direction, okay, which is around the x-axis, okay? And if you do the right hand rule, you should get your thumb pointing in the positive x direction, okay? So we're gonna have TA, right, positive TA, and then what distance? The distance needed, the perpendicular distance to the pivot point, I guess, or the pivot axis, which is going to be this distance over here, which is 3 feet, okay? Oops, 3 feet. All right, the next force is this 200-pound force, and now this is trying to make it bend downwards this direction, which is clockwise. Okay, so it's gonna be minus 200. And now what distance? Well, so it intersects x. I have to move it 3 feet again. The 500-pound, again, this is trying to make it bend downwards or like rotate in this direction clockwise. So it's going to be minus 500 times, we know it's halfway through, so this distance over here is 1.5. Should be half of 3. put that down. Good. And now one more. We have TC, all right? And now again, that one's kind of like TA. It's trying to make it rotate in this direction, counterclockwise. Okay, so it's going to be positive TC times a distance of 3 equals 0. Okay. And now we start to see the light here. We have 3TA plus 3TC equals, let's bring all those negatives to the right hand side. So we have 200 times 3 plus 500 times 1.5. 1350. Okay. And now let's do it about the y. And we won't need it about the z because all these forces are parallel to z. So they're not trying to make it rotate about z because the force and the pivot point, or this axis, they're parallel to each other. And we know tau, or the rule for calculating the torque is RF sine theta. So if they're parallel, this angle here is 0 or 180, okay, which is 0. So 0 torque contribution from anything that's in about the z-axis, by anything that's along the z direction. So let's look at my. So anything that's on y already doesn't count. So we already have TAs acting on y. Okay, so that has no contribution to the moment. Then we have TB, right? TB is trying to make it go this way. Okay. All right, which is negative. So it's negative TB times 4. Okay. Negative TC, because that's there as well, times 4. All right. Then plus 200 times 2, and then plus 500 times 2, because it's halfway through this length. Okay, it's right there. That length is 2. Alright, so let's calculate this. This will give me a 4 TB plus 4 TC equals. So that's 400 times 2, 400 plus 1,000, 1,400. Alright. And so now we have 3 equations and 3 unknowns. So now we can solve for one of those. Okay. The way to do this is one quick way of doing it is say, okay, factor out the 4 here. Okay. You have TB plus TC equals 1,400. Okay. And then 1,400 divided by 4, that's 350. Equals 350. Alright. And then you know that TB plus TC equals 350. So if we go to that first equation up here, we have TB plus TC. Okay. Let's switch to yellow. TB plus TC. So these two, this arrow, and these add up to 350. So then we can have 350 plus TA equals 700. And then TA will just equal 700 minus 350, so that's 350. 350 pounds. Okay, so it's 350 pounds. Let's substitute that into this equation up here, or down here. All right, and then we have TC. Okay, so we have 1350 minus 3 times 350 minus 3 TA divided by 3. And we have TC is 100 pounds libras. Okay. So TC, and then last but not least, we can just plug that in here and we can get TB. So now leapfrogging all the way down here. We have 350 minus TC, which is just 250. So 350, 250, and 100. Boom. Okay. So the new idea here was taking the moment about some axis. Okay. So you can if the force is parallel to that axis, it won't contribute any torque. Okay. Just keep that in mind. All right, guys. That's all for this problem, and now we'll start getting into a few more complicated ones with actual supports. Okay. Thanks a lot. Have a good one.